Welcome to demonstration of our new motor design software. Today I will walk through the complete process of designing and simulating a motor, from setting the first parameter to seeing the final performance results. We begin in the motor type tab. We have many options available here, so we can select the exact setup we need. For this project, I am selecting PMSM with inner rotor and motor type is SPM. Finally, we set our base running parameter, including a rated speed of 120 RPM and friction and windage loss of 10 watts. Next, we move to the motor geometry tab, where we enter the material and size detail of our design. We select the standard electrical steel for the stator and rotor, copper for the winding, and specific exact grade of our permanent magnet. As we enter the details of our stator stamping, clicking the stator preview shows a 2D cross-section using in FMM solver. We do for the same for our rotor geometry. Notice how the software clearly shows the magnet placement and air gap shape, so we can easily check it visually. Also, we offer skew angle option for both stator as well as rotor, supporting both step and continuous skew. Moving towards the winding tab, we set up a double layer winding layout. To get layout, you can simply visit our website uh, and use our winding calculator. By entering the slot and pole count, gives the multiple winding layout, also showing important data related to winding. You can explore it at our website. You just enter this slot table in our software along with your wire size and overrun dimension. Then click on the preview winding. You will get detail about your winding layout. The software also instantly calculate the phase resistance and slot fill factor to check manufacturing feasibility, that is critical parameter. Now we go to the simulation setup tab. We select the MTPA. There are multiple options. You can also custom. Enter the maximum or peak current of your motor. The software allows you to choose the exact simulation options you need. For this run, we are checking for the back EMF, cogging torque ripple simulation, torque speed curve, efficiency map, and loss calculation in detail. A simple click on the simulate, start the solver. I have already done that. When the simulation is done, the result tab gives a clear table of all important information related to your drive, flux at no load, flux at full load, the power, then whatever your losses in our motor, back EMF, exact calculation of your back EMF, then torque and the material content and overall efficiency of your motor. Finally, the graph tab gives a clear visual chart to understand the motor performance. We can look at the back EMF voltage, that is induced voltage at your open circuit, then the cogging torque, air gap flux density for our motor. Specifically, this is the radial flux, This software creates important information chart, including torque speed curve, power speed curve. This clearly shows the constant torque area and field weakening range up to high speed. To help make the motor as efficient as possible, we provide detail of color map across the motor full speed range. This include overall efficiency map as well as loss breakdown versus speed, again the copper loss versus speed, core loss versus speed, magnet loss versus speed. This gives you exactly what you need to verify your thermal and magnetic performance of your design. Thank you for watching this complete motor design overview.